Welcome to VT engineering class. In today's class, we are going to look at deflection of beam. We are still using double integration method, and for case 2 we'll be considering a beam carrying uniformly distributed load. As you can see on the board, I've already drawn the diagram, and I will explain how how the beam behave when it is uniformly distributed. So if you look at this diagram very well, you can see that the beam is uniformly distributed, and W is what in unit length. That is the weight of on top of the beam is per unit length. L is the length of the beam, and RA and RB are the reaction at the support of the beam. So now, before considering the deflection of the beam, so if we need to calculate our RA and RB, as you can see that W is what is per unit length. So for us to get the total weight acting on the beam in point load, we need to convert this W to point load, which is what capital letter W, to denote our what, our weight per unit length. So now, so if we want to convert it to the total weight acting on a point load, it will be what W what multiplied by length, which is what W multiplied by length, which is what will give us a load acting at the center. So at this case now, for us to get our RA now, so if I want to calculate my moment at RA, summation of moments at A will be equal to 0. Then I'm considering my coordinate, which is what upward force should carry positive and downward force should carry negative. So in this case now, for me to calculate my moment at RA, and I know that the total load acting on this, acting at the point here is what WL. So now, if I convert this one to WL, this one I've already converted to WL, like this. WL is going to be RB. I have the force here, which is what RB, and I have the force here, which is what WL. So now my moment at A now is going to be what RB is what upward force, which is what I've already given my upward force what positive. I'm going to have what RB multiplied by the distance covered before it reach RA is what L. Then this downward force is what WL minus WL, and it's acting at where WL is acting at here, which is what L over 2. So WL into bracket what L over 2 equals to what 0. Then I'm going to have my what RBL equals to what WL square over what over 2. Then I'm going to divide both sides by RB, which is what RB equals to what WL square over 2 divided by what L, which is what RB equals to what WL square over 2 multiplied by 1 over L, which is what reciprocal. So this one is going to cancel 1 here. So my RB now is going to give me what WL over 2, which is what this place now is what WL over 2. So in this case now, I've already find the value for my RB. So I need to find the value of my RA. But for this beam to be in equilibrium, we know that the sum of the upward force must be equal to the sum of the downward force, which in this case it will be what? The sum of the. So now I've only find the value of my RB, that is the weight of WL must be equal to what RB plus what RA. Therefore I'm going to have what RA plus what RB WL, and the value of my RB is what WL over 2. So in this case now I have what RA plus what WL over 2 equals what WL. So now in this case now my RA will be what WL minus what WL over 2. So the value of my RA now is what WL over 2. So I've already find the value of my RA, which is what WL over 2. So now I'll find the reaction at both the RA support and the reaction at RB support. So now by mere looking at this case, you can see that this is a uniformly distributed load, right? But if we look at this very well, we can see that if this beam is going to since when we are calculating our force, we have already converted to point load. So if this beam is going to deflect, the deflection is going to be in this way. Yes. So deflection is going to be in this way. So now for us to calculate the deflection, so now let's section a part. It may be A or B to calculate our deflection. Assuming that I section this part now. Section XX at a distance X. So now for me to calculate deflection at section XX, so now considering section, so now considering section XX at a distance X from B, I'm considering this section at this distance X from what? From B now. So for me to calculate my moment at this X now, so now moment at X now is what? Moment is what? Force times perpendicular distance. And in this case now, I only have one force here, which is what? RB. And RB is moving what? In what? Anti-clockwise direction, which is what? Positive. And the distance covered before it reaches this point is what? X distance. So I'm going to have what? RB multiplied by X. So now RB multiplied by X. But at this point now, from here to here is what? Is a uniformly distributed load. So I still have what? A force here, which is what? W multiplied by the distance covered, X, which is in downward direction. So minus WX. So now WX now at this point now will be acting what? Yeah. This from here to here is what? X. So at this point now is what? X over 2 and X over 2. So it will be covering X over 2 distance in what? In clockwise direction. WX multiplied by what? X over 2. This is my moment at what? At this point X. But don't forget from our previous one, we have already proved that what? M equals to what? EI the square y over the x square. So now since moment at this point now is what? Is this one, and moment is also what? EI the square y over the x square. So definitely this one is what? Is equal to this one. So we now have what? EI the square y over what? The x square equals to what? RBX minus WX times x is what? X square over 2. So now, but don't forget that the value of our RB is what? WL over 2. So now we have what? EI the square y over what? The x square equals to what? This one is what? WL over 2. WL multiplied by x. WLX over what? 2 minus WX square over 2. Let's call this one what? Our equation 1. So now, we have already gotten our equation. The next thing for us to do is what? To integrate. We are going to integrate. So we are going to, when we integrate, we are going to have the equation for slope and for maximum slope. So now integrating this equation now, so now if you can look at it very well, you can see that from here our moment is this one, and this one also is what? Our moment. This one is equal to this one, which is what is here. You understand now? But the value of our RB is what? WL over 2, which is WL over 2 multiplied by x will give us WLX over 2 minus WL square over 2, which is equal to our what? Our EI the square y over the x square. But don't forget that this one is what? Second order of what? Of integration. So now the next thing for us to do is what? To integrate with respect to x. So if we integrate this equation 1 with respect to x, we are going to have EI dy dx equals to what? So now I'm integrating this one now. I'm going to have WLX. So now there's an invisible one here. When you add 1 to it, then you multiply it by what? By your denominator. So I'm going to have x squared over what? Over 4 minus WX. In this case, we have 2 here plus 1, which is what? 3. Then we multiply it by our denominator, which is going to give us what? WX keyword over 6 plus C1. This one is our what? Equation 2. But in this case, our C1 is what? Our first constant of integration is obtained when at this point, our first constant of integration is obtained at this point when x is what? L over 2 and the y dx is equal to 0. So let's substitute x equal to L over 2 and the y dx equal to 0 in equation 2. So now automatically the y dx equal to 0, this one will be equal to what? 0. So we have 0 here equals to what? Our x is what? L over 2. So we have WL. Our x is what? L over 2. L over 2 square over 4 minus W. Our x is what? L over 2. L over 2 cube over what? Over 6 plus what? Plus C1. So now in this case now, if C1 stay in this side and this one goes to the other side, we are going to have here is going to be what? This one is going to come to this other side, it's going to be what? Negative. And this one is going to be what? Positive. Then we are going to have W into bracket what? L over 2 cube over 6 minus WL L over 2 square over 4 equals to what? C1. So now in this case now, L cube is what? We are going to have WL cube. 2 cube is what? 8. 2 times 2 times 2 is what? 8. 8 multiplied by 6 is what? 8 multiplied by 6 is going to give us what? 48 minus this one is going to give us WL cube over this one is 2 squared multiplied by this one is going to give us 16 equals to what? C1. So now in this case now, our 48, we are going to find LCM. We are going to find LCM and 48 will be the LCM of what? 48 and what? And 16. So now 48 in 48 is going to be 1. Then 1 multiplied by WL cube is going to give us WL cube. This negative is here. So now 16 in 48 is what? 3. Then 3 multiplied by WL cube is what? 3 WL cube. So now we have now this one is 1 and this one is what? Negative 3. So we have negative 2 WL cube over 48. Then 2 here 1, 2 in 48 is what? 24, which is equal to what? WL cube over what? Over 24, which is equal to what? Our what? C1. Therefore, C1 equals to what? Minus WL cube over 24. So as you can see that you have got our value for what? C1. So what next now is that to substitute the value of our C1 into equation 2. So we get the equation for slope. You understand now? So I hope you are following. So now if we substitute the value of our C1 in equation 2, then we are going to have what? We are going to have what? EI dy over dx equals to what? W Lx squared over 4 minus W x cube over 6 plus C1. But our C1 is what? Negative WL cube over 24. Negative WL cube over 24. These are what? Equation 3. And this equation is what? Equation for slope. So now, but as you can see, maximum slope can occur at this point. Maximum slope will only occur at what? At this point A and B. This is where we are going to have what? Our maximum slope in this view. So now, for maximum slope to occur at what? At the end, which is what? A and B. And at this end what? And at this point N, if we are considering section XX at this point, X is what? Is 0. And if we are considering this section at this point B, X is what? 0. So now maximum slope occur at, so maximum slope occur at what? A and B when X equals to 0. So our equation now remain what? EI dy dx equals to what? When X equals to 0, automatically this one is equal to 0 and automatically this one is equal to 0. Then we are left with what? Negative WL cube over 24. Negative WL cube over 24. So now, if I'm considering this from, if I'm considering section SX from B, so now my slope, which is what? Dy dx, is my slope. So my slope from B now, dy dx, let me just write it as what? Theta, which is what? My slope is what? I'm considering for what? From B. So my slope dy dx is what? This one is coming to this other side. I'm going to divide both sides by what? EI. So now I'm going to have what? Minus WL key over 24 EI. So and by symmetry. This one is when I'm considering my slope from here, my maximum slope from B. And if I'm considering my maximum slope from A now, by symmetry, by at A will be equals to what? WL cube over what? 24 EI. So these two equations, this one and this one, are what? Equation for what? Maximum slope. So now since we have our equation for maximum slope, the next thing is what? To determine our what? Equation for what? For deflection, and to determine at which place is going to be the maximum deflection. So now for us to get our equation for deflection, we are going to integrate for the second time. So now integrate. So now we are going to integrate in question 3 for us to get what? Our equation for what? For deflection. And this is what? Our equation was? Equation 3. So if we integrate equation 3, we are going to have what? EIY equals to what? WL. So now we have what? X squared here. You understand? So now for us to integrate this x squared now is what? 2, this, the power of 2 is what? Plus 1, then multiplied by what? By the denominator, which is what? WLX cube over what? Over 12 minus. So now we have what? X cube here. You understand now? So for us now is what? To add 1, then multiply by the denominator, that is what? WX4 over what? Over 24 minus WL. If you can see here that we don't have x as a variable, so now x, so WL cube over 24 is what? A constant. So we are now going to introduce s as our integration. WL cube x over what? Over 24 plus C2. These are what? Equation 4. And C2 now C2 is what? Second constant of integration obtained at what? At this both end A and what? And B, when x equal to 0 and what? Y equals 0, because at this both end there is no deflection. You understand? And at this end B there is no deflection. So our x and our y is equal to 0. So now definitely our C2 in this equation, since our y equals 0, x equals 0, x equals 0, x equals 0, our C2 is what? C2 will be equals what? 0. So now we are going to have our equation back as what? EIY equals to what? WLX cube over 12 minus WX4 over 24 minus WL cube x over 24. These are what? Equation 5. And equation 5 is what? Is the required equation for deflection. Equation. So now this is our equation for what? For deflection. So now for us to have our maximum deflection, if you look at this diagram very well, you can see that our maximum deflection will be what? Will be at this midpoint. At this point we are going to have our maximum deflection. So now for us to have our maximum deflection now, so maximum deflection occurs at midpoint when x is what? L over 2. So now maximum deflection at this point occur what? At midpoint. And at this midpoint the distance is what? L over 2, and from here to is what? L over 2. So now what we are going to do next is that we substitute whenever we have x, we put L over 2 into what? Into this equation. So now what you are going to do is to put it. I hope you are following. So now we are going to have what? EIY equals to what? Here we have x, which is what? L over 2. We are going to have WL. Our x is what? L over 2. L over 2 cube over what? Over 12 minus WL over 2, sorry, over what? Over 24. So now, so from this now, so this one now we are going to simplify it. So now we are going to have what? EIY. So now here we have WL and we have L cube here. It's going to be what? WL4. This place is what? 2 cube. So 2 cube multiplied by 12 are going to have what? 96 down minus this place now we have L raised to power 4, which is what? WL4. So WL4 over here is what? This one is what? 2 raised to power of 4. And 2 raised to power of 4 is what? 2 raised to power 4 is what? 16. 16 multiplied by 24 is what? 384 minus, in this case now we have WL cube multiplied by L is what? WL4. And we have 2 here. 2 multiplied by 24 is what? 48. So now what we are going to do next is what? Is to what? To find the LCM. So if we find the LCM of this one now, we are going to have what? 384. 96 in 384 is what? Is what? 4. 4 times WL cube is what? 4 WL4. This negative is here. 384 in 384 is what? 1. So we are going to have WL4 and this negative is here. So 48 in 384 is what? 8. 8 multiplied by this one is what? 8 WL4. So now our EIY equals to what? We have positive here, we have negative and negative here. So we still have 4 WL4 minus this one, negative WL4 minus 8 WL4. It's going to be 9 WL4 all over 384, which is what? EIY is going to be what? Plus WL4, positive WL4 minus negative 9 WL4 is going to give us minus 5 WL4 over 384. So now our Y maximum is what? 5 minus 5 WL4 over 384 EI. But look at this diagram. Don't forget that our weight is what? Is per unit length. So now if we are considering our weight when we convert it to point load, so our weight per unit length here is what? Capital letter W, which is what? The total weight acting on the point load now. So now in this case now, our Y still can be what? Since WL equals to what? Capital letter what? W now. So we are going to have our Y is what? Minus 5. WL is what? Capital letter what? W. So we are going to have W L key over 384 EI. So this is the what? Equation to calculate for maximum slope, which is going to occur at this point. So thank you for watching this bit engineering class, and please reverse us to your friend who might be in need.